So in this video, we are going to learn about, uh, we are going to do some paper two questions which are related to the energy of the reaction. So first, this is a question and what they are saying, sulfur reacts with this F2, okay, and they are basically forming SF4, okay. Then what happens, the reaction they are basically seeing is exothermic, okay, and they complete the energy level diagram, include an arrow which clearly shows the energy change. Energy change is basically the enthalpy change. Okay. So if exothermic reaction is there, then we know that reactants are at higher energy state. So they are at high energy state. The graph will become like this one. Okay. And the products would be at lower energy states. These are basically products. You can mention the products here. Product is only SF4, so SF4 can be mentioned here. Now we have to find out which is the enthalpy activation energy. So activation energy is basically from this point till the reactant's energy. So this is basically activation energy, and enthalpy change is the difference between the energy of the reactant and the product. So it would be in downward direction up till this point because it should be at the same level as the products. So delta H here needs to be negative. Is that clear, Ayan?
Yes, sir.
Okay. Now, this was basically the graph that we have to draw for exothermic reaction, and enthalpy change, activation energy and enthalpy change are important to mention here. Okay. So let's move further. What they are saying, during the reaction, the amount of energy given out is 780 kilojoules per mole. That is given out. That means the reaction must need to be exothermic. Okay. So now we know for enthalpy change and the reaction which is the energy which is given out, that is 780. So we know active enthalpy change for exothermic reaction is always negative. So the formula would become enthalpy change, okay, is equal to energy. Yes, what is the formula? Energy absorbed during, yes, during bond breaking.
Formation.
Bond breaking. First, the bond breaking will come. Okay. Energy absorbed during bond breaking minus energy released during bond formation. Bond formation. Okay. So now, first, energy absorbed during bond breaking is basically on the left hand side. Okay. So this is only sulfur. So there is basically no bond breaking occurs at this point. But here, there are two bonds, two fluorine bonds. So they are going to be broken. And the energy, first of all, enthalpy change. What is enthalpy change? That is 780. They have already given us. So that should be minus 70 here. Okay. Energy absorbed during bond breaking. So you are going to multiply 2 with what is the energy for FF bond they have given us, that is 160 minus, this minus is going to be put here. So there are, how many bonds are there? 1, 2, 3, 4. So 4 bonds are basically present here. Is that clear? Multiply by,
Yeah.
we have to find its energy. So we are going to write SF like this. Now, let's see about how we are going to calculate it. So it's minus 70. And when it is multiplied, 2 is multiplied with 160, that would become 320. is minus 4 into SF. Okay. Then what we need to do, we are going to take 320 over there. So that would become minus 70 minus 320 is equal to minus 4 into SF. Okay. Now, we are going to add them. So what is the answer? Can you please tell me? Yes, बेटे आंसर से कैलकुलेट करें माइनस माइनस को ऐड करें.
Um,
जी बेटा क्या आंसर आ रहा है?
780
प्लस
minus,
plus because we are going to add them as they are minus on both ends.
yeah, 1100.
1100. Okay, so it's minus 1100 is equal to minus 4 into SF. So minus 4 will go there. So what is the energy would become for SF is equal to minus 1100 divided by minus 4. Yes, what is the answer? Yes, Betty, what is the answer that comes out to be? 1100 divided by 4.
Um, 275.
275. So 275 is basically its answer that we are going to write here. 275. Okay. That is in kilojoules per mole. Now let's move further. Yeah, is that clear? Do you have any confusion in this question?
I didn't hear you properly. What?
I'm saying, is that clear? Do you have any question?
Off. No, sir.
Okay. So let's move further towards next question. And that is basically from. Okay. So use the basically you can see these are reactants on the left hand side. So what they are saying, they use the following energies to determine whether the reaction is exothermic or endothermic. You must show your reasoning. So Ayan, what is the formula to find out delta H first? Tell me. Energy. Yes, energy.
Energy activation.
Energy absorbed. The one we have done up now. The energy absorbed during. Yes.
During bond from
During bond breaking minus. Yes. Energy.
energy formation.
Energy released. Yes. Energy released during bond formation. Okay.
Bond
So,
formation. Yeah.
yes. So now let's see whether this reaction is exothermic or endothermic. So how many carbon hydrogen bonds are here? One, two, three, four. No. One, two. Then we have three, four, five, six, seven, eight. This is carbon hydrogen bond. They are eight carbon hydrogen bonds. Okay. You can see it once again. One, two, three, four, five, six, seven, eight. So there are carbon hydrogen bonds are eight. You are going to multiply eight with carbon hydrogen bond, that is 412. Okay. Plus, how many carbon carbon bonds are there in this one? There is one, two, two carbon carbon bonds. Okay. So you are going to multiply two with
Okay.
348. And then let's see about this chlorine. Only one bond is there. So we are going to multiply add 242. And we are not going to multiply it with any number because there is only one chlorine bond. We are going to add it, then we are going to subtract it. So let's see what would be the answer for that. Energy released during bond formation. Let's see how many bonds are on the right hand side. So let's see how many carbon hydrogen bonds are there. 1, 2, 3, 4, 5, 6, 7. There are 7 carbon hydrogen bonds. So let's make it as like this. 7 carbon hydrogen bonds. So you are going to write 412 with 7. And then you are going to add how many carbon bonds are there? 1, 2. So there are 2 carbon bonds. What is for carbon bond? That is 342, 348, sorry. And then we are going to add it for uh, carbon chlorine. So how many what is the energy for carbon and chlorine? That is 338. So there is only one bond. So we are going to add 338. Okay. Now we are going to add one more energy for hydrogen and chlorine. There is only one bond, so we are going to add 431 in it. Okay. Now let's add them together. What is the answer when we are multiplying 8 with 412? Please open the calculator and find out. Yes, 412 multiply by 8. So it's 3296. Okay. Then 348 is multiplied with 2 and that would become 696. Okay. Wait, I have to add one more thing here as well. Okay. So that then we are going to add 242 here. Then minus 7 multiplied by 412. So that is 2884. Ayan, you can add them together. You can add them together until I do these things. Okay. So then we have so then we are going to multiply with these things. Just okay. Then we have 2 multiplied by 342 48, and the answer would become 348 multiplied by 2. So it is 696. Then we are going to add 338 and then 431. Okay. So now let's see what is the answer here. Yes, Ayan, what is the answer here?
So
That is 4234. So what is the
okay,
answer here? 2884. Yes, Ayan, please calculate it.
that's 696 plus 338
Yes.
plus 431,
Yes.
4,349.
4,000. 3.
300, 4,349.
Yes, now subtract them. So what is the answer? Answer should be negative.
Yep. 4234 minus 4349 minus 115.
Minus 115 kilojoules per mole. So we have to see this thing that answer delta H is basically in negative. If delta H is negative, then we know the reaction is exothermic reaction. Okay. So this is what we have to tell them. Because they asked us that whether the reaction is exothermic or endothermic. So we have to tell them that the reaction is exothermic. So let's move towards the next question. And yes, you have done this correctly. Like, give two reasons why a catalyst is used. So we know that it basically increase the rate of reaction by decreasing the activation energy. Okay. And then we can also write that with the catalyst, there'll be low temperature would be required and decreases the cost. Decreases the cost. Definitely, if the temperature requirements are lower, then basically cost would be decreased as well. So there's a question. Ammonia is used to make nitrogen trifluoride. Nitrogen trifluoride is essential to the electronics industry. It is made by the following reaction, that is this ammonia, and then it's reacting with three molecules of fluorine, and it's forming nitrogen fluoride and then hydrogen fluoride. So what they are saying to us, they are saying this is FF bond. How many FF bonds are there? Yes, Ayan. How many FF bonds are there? How many FF bonds are there? Yes, tell me.
There are 6.
No. How many bonds are there? How many bonds? I'm asking about how
Ah,
many
3.
fluid. Yes. So we are going to multiply 3 with FF, and that is, what is the energy for fluorine? Fluorine, that is 155. So answer comes out to be, yes, calculate the answer, please.
465.
465. What is for nitrogen
Sir, can you give me
fluoride?
a second? I'll come back. Sir, just give me a second. Hold on.
Okay. So how many nitrogen and fluorine would be there? Nitrogen fluorine bonds are there. Yes, tell me. How many nitrogen fluorine bonds are there?
1.
Nitrogen fluorine. This is nitrogen fluorine. How many
Ah,
nitrogen fluorine?
3.
Yes, there are three. And you are going to multiply it with?
280.
Yes. So what is the answer?
840.
840. And how many hydrogen fluorines are there? Yes. How many bonds are there?
3.
Yes. So you are going to multiply 3 with?
565.
So what is the answer?
1695.
1695. So what they are saying us now, determine if the reaction is exothermic or endothermic using the following bond energy and by completing the table below. So how we are going to do that? In the same manner, we know enthalpy change is equal to, let's do it here, that is energy absorbed during bond breaking minus energy released during bond formation. Okay, so enthalpy change is equal to, that is, how many nitrogen hydrogen bonds are there? So there are three nitrogen hydrogen bonds. So we are going to multiply it with, we have already done it. So we are going to just put the values here, and the values comes out to be 1170 plus. How many fluorine bonds are there? There are three bonds, so I have taken the value 465. I'm going to put bracket here, and energy released I'm going to write here, and there are basically three bonds, so it's 840, and plus how many hydrogen fluorines are there? So there are three bonds, and that would be 1695. Yes, please add them. 1170 plus 465. So what is the answer?
It becomes
That is
1635.
okay, great. Minus. So what is the answer here? That is 840 plus.
2535.
Yes, 1695. Yes, that would become 2535.
Minus 60.
Now, what is the answer here? 1635 minus.
Minus 60.
No, it's minus 900. 1635 minus 2535. Am I right? Yes.
Let me check again.
Yes. So the answer is
Yeah, minus 900.
minus 900. So the reaction delta H here is negative, and we know delta H is negative for exothermic reaction. Okay. So this is what we have to mention around here. So I think there is no other question which is left. Yes, that's fine. So this is all about P2 of uh, energy of reaction.